everybody. I'm Pedro. I'm a member of the Remix team at Shopify. And I work a lot on the compiler and the dev server. That's kind of my area of passion. But there's only 6 of us, so we all pick up and do whatever we need to do to make things run. Before I actually start giving the talk, I just want to call out that a lot of this work I paired with Jacob, also on the Remix team on. So I'm really just representing both of us up here. All right. So with that, let's see. It's not working. Oh, got to turn it on. All right, so let's talk about Legendary DX, developer experience, and the quest to get to it. So, sorry, one sec. There we go. So what is developer experience? This is what I think of when I think of great developer experience, right? It means you're staying in the flow, and you're making changes, and you're seeing those changes reflect immediately in what you're doing, right? And that flow is just, it's so key for you to stay in the loop and be able to say yes whenever your designer asks, oh, can you do this? If you're fighting your tools the whole time, you're going to be working on that instead of the actual core domain of the problem you're trying to solve, right? So 2 things you need, like I said, are rapid feedback. But the other thing that you need is you need to understand your tools in order to get the most out of them. So I'm hoping to talk about both of those things today. I want to show you guys how Remix is going to give you that rapid feedback. But I'm going to dive deep and show you exactly how it all works under the hood as well so you understand that tool. All right, so let's start by looking into past approaches that we could have used for great DX. So first up, really simple file server. This should just be a review for everybody. So you've got a browser, and you've got some files that you want the browser to run. And you just write those directly. And when you visit a page, the browser just grabs those from a file server and puts them up and renders it. Pretty easy. But we're devs, so we're not satisfied with that. We want to write with nice tools like TypeScript, and we want to use ES modules, and we want to use things that require a build step like Tailwind. And so we're going to write our code like that. And we're going to need a compiler to turn those files into those assets that the browser wanted. So here you can see the compiler's compiling those files for us, and then when the browser asks for a request, it grabs those assets, and again renders them like normal. Pretty easy. And then when you make any edits, if your compiler supports it, it can watch for those changes and recompile a file, so now you've got those assets updated. But the browser's not going to pick those up, right? It's just sitting there. And so you're going to have to refresh manually every single time you want those changes. And that's very annoying. So let's solve that. So there's a technique called live reload. And what live reload does, again, you're going to edit your files. The compiler's going to see that and push those changes to the assets. But now we're going to send a refresh signal to the browser. And so there's a tiny, tiny bit of JavaScript in the browser that picks up that signal and just calls a refresh. So now the browser's refreshing. It goes back to kind of an empty state where it's going to fetch the assets again, and it's going to pick up those changed assets. And that's great. Now we've got the changes in the browser, and we don't have to hit reload every single time. But there's something else that's wrong with this picture. Let's say you're working on something super stateful, like a giant form, and you have to fill out hundreds of inputs, and only once you fill them all out can you see if things look right. Maybe you're testing submission or error states for that form. Then if you're nudging the little error message to the left or right, or changing the color, or things like that, well, live reload is going to see those changes, and it's going to make the browser just forget all of those inputs that you just wrote. And that kind of sucks. So let's talk about hot module replacement. So before I dive into it, I just want to call out that Webpack, Vite, and Snowpack really formalized and pioneered all this space. And so we're using a lot of stuff inspired from there. So thank you to anyone who worked on those awesome projects. And then our implementation right now also makes use of React Refresh, which is a way to let React handle the changes that are coming in for the UI. So what is hot module replacement? Can I get a show of hands? Who's used HMR with Webpack or Vite or anything like that? OK. And who feels like they could explain HMR to a coworker? OK, yeah. That's how I felt in November, right? And then Ryan was like, hey, we really need to do this HMR thing. And I was like, oh, crap. So then I started trying to learn all this stuff as quickly as I could. So the way to think about it is that hot module replacement is about taking the changes that you made and just swapping them out without disturbing anything else. Right? You don't want to make the boulder come down. You don't want to make your browser refresh. You don't want to make things crash. You just want to surgically remove the changes and add in the new stuff. Right? There's some techniques for how to do this that are pretty advanced. I'm just going to keep it at that high level for now. If you're interested in kind of the internals of how this works, I've got a repo where I implement HMR from scratch. You can check that out. You can come talk to me about it. So I'm going to represent this hot swapping with a little Indiana Jones icon so that we keep it in our heads. This is also known as the HMR runtime, if you've ever heard of that. OK, so how does that work? So again, we're going to have our files. The compiler is going to compile them. And now we have our HTML, CSS, and JavaScript. But we also have this little hot swap JavaScript stuff running inside of that file. And when the browser asks for those assets, we're going to give it to them. But now, instead of just rendering like normal, to the user it looks the same, but we have this little JavaScript just running their script, waiting for updates. So now when the compiler sees those changes and pushes those new assets, instead of sending a refresh signal, we're going to send just some representation of those updates to our hot swap helper here. And Indy is going to process those, and it's going to determine what changes need to happen in the DOM, right? It might mutate the DOM. It might be doing like some crazy jQuery stuff for all you know, right? Like it's just making those changes appear somehow in the browser. And great, now you've got an updated browser, and you notice the browser never went down, right? It never had a restart or refresh or anything like that. So that's the power of HMR. So let me show you HMR in Remix. Here we go. All right. So let's pray to the demo gods. And luckily, I don't have any internet requirements from this. So let's run the dev server. All right, and let's go to localhost 3000. And this is a little demo that I stole from Ryan's workshop, but I added a couple little things just to show off HMR. And I've got the network tab open here just so you can see what's going on. This is the initial load, loads a bunch of chunks and all that stuff. I'm just going to clear that so we can see just what changes. And then in a separate tab, I'm going to go ahead and open up my editor. And I'm going to look at the root route. There we go. Awesome. So let's say you were messing around with this form and you were putting some stuff in here, and live reload kicks in. Like I said, if you do a hard refresh, that stuff just goes away, right? But with HMR, what you can do is you can leave that in there. And now I can change this awesome title to say yo. And let's also change the color. Let's go here and change this to amber 500. All right, that seems good. So when I save, those changes get picked up, and now they're just in the browser for you. And you can see the input is still preserving all of its state. So that input's obviously very simple, but you can imagine like a giant modal, bunch of forms, bunch of stuff that you're doing that you don't want to rerun. Maybe your loaders are really slow and you don't want to rerun those because you just made UI changes, right? So that keeps it all there. And you can see that the only things that we brought in from these fetches are only the things that changed. All the other assets from Remix didn't get pulled up. It's only the things that changed. I think that's pretty cool, right? So that's HMR, but there's something a little complicated here, which we have to talk about, which is that we have a server. And really, a lot of the HMR experiences that have been designed before were for client-side rendered only apps. So how can we adapt what we have for server stuff? Because what if you change your loader? What's going to happen then? So let's say that we've got this server file. So this is something that the compiler is going to spit out for us from Remix. And then the sunglasses is going to represent the actual running server. So if you call node server.js, that's what that is. It's a process. OK, so again, we're going to compile your stuff. You see all the usual suspects, but now we've also got the server.js file coming out. And now we're going to node run it. And that's going to instantiate our server. And that's starting up on localhost 3000 by default. And now the browser asks the server for things. It doesn't grab the files directly. It asks the server. So the server can bring up those assets and might compute some data and send it up. So now you've got also your loaders are running. So in this case, we're just passing place world. And great, that works. But what happens when you make changes to this? So let's say I make a UI change. So instead of hey there remix conf, I'm going to say hey there friends. And instead of passing place world, I want to change this API. I want to say location Salt Lake City, right? So I've changed both the schema and the value. And I want to make those updates as well in the UI, pass those through. And I hit save. So let's see what happens. So you save that, the compiler sees it, and you get a new server.js file and new assets. But notably, the server isn't running that new server.js file. It's still the old server, the existing process with all that old code. And so now when we send those UI updates to Indiana Jones for us to parse and compute, it's going to start mutating the DOM, but there's a problem here. All that UI code was expecting location, but it still has the old data, right? It's still looking for place, but now we're calling it location. Now, obviously, as a simple example, you just get undefined. Maybe it's not a huge deal. But for more complex things, this could like crash your browser. It could cause all sorts of issues. We've got this kind of mismatch going on. So let's just show that in Remix, just to show the limitations, because there are some things that you can't really fix. So let's say here I'm going to add something like stuff. Shouldn't work. And then let's go ahead and, actually before I do that, let me just pull this like that. And let's go ahead and pipe that in here. I'm just going to do a full refresh just so we can see exactly what's going on. And let's add some state back in. Cool. OK, so now I'm going to modify the loader. So let's add stuff. This shouldn't work. And now down here, let's add like an H3, and let's put data.stuff. So when I save, you'll see that this crashes and it doesn't. Oh, wait a minute. That's kind of interesting. I got opposite luck here. Everyone's demos have been a little rough, but mine, how's that working? OK, but let's see here. What if we go into, let's say, our route for this store? OK, so we've got a loader here, and this is loading up all the data for these this grid of products. And it's coming from this fake getProducts call. So that's probably just a bunch of hard-coded data. So it's just like an in-memory thing representing our database, right? OK, so that worked, but like this time I'm not editing the loader. This time I'm editing like data that the loader depends on. So, well, at least I can show that this doesn't work. Huh. That's kind of weird. So this is something we call hot data revalidation. And I'm going to talk about it a little more, how we accomplish this. So did we like combine the dev tools with your app server? Maybe that's a way to do this, because we need to coordinate these two things. And maybe we could just like call the dev tools from within our app server. That might be one way to do it. That kind of changes what your app server looks like in dev. And I don't really like that, right? Because that's going to mean that the bugs that you encounter in dev and prod are going to be very different. It also means that the performance characteristics of your app server in development are going to be really different. So I don't think that's a good approach. But maybe like we can get close enough and not have a bunch of bugs that are different, and we can keep the perf pretty good. Like maybe that's still a good idea. Can we like just run the dev tools within the app server? Well, the thing is, Remix can run on all these runtimes. And if we want to run the dev tools on all those runtimes, I have to write the compiler in all those runtimes. Now, Jacob actually has a prototype for that, but I don't want to like have to do that, right? And the other thing too is like some of these runtimes aren't actually long-running servers. Like if you're doing Arc or Cloudflare stuff, sometimes you can only process stuff during the request. And so if things change in your source files between requests, like you got to wait until the request for the compilation to kick off. And that's not legendary DX at all. So this is another reason why we don't just call the dev tools from within the app server. So what do we do instead? Well, the key idea here is, well, what if the dev tools, the compiler, could listen and just wait to do all the HMR stuff until the data is up to date from the server? So that's the key idea. So let's see how that works. So for this, we're going to promote the compiler to actually be a server. So now this is a dev server. And it's really just the same stuff that it was before. It just has the ability to listen to this one little endpoint that just listens to see if the app server is ready. That's it. So again, the compiler will compile your files. You'll run your server. That looks normal. The browser fetches the initial assets. That all works as normal as well. We've got the HMR runtime running in there. And now we're making our loader and UI changes. The compiler picks that up, and it makes changes to both the server file as well as the assets. But now, instead of sending the diff, all those changes, to our HMR runtime right away, we're going to hold off. And we're going to listen. And we're going to give a chance for the app server to look at those changes, that process will be killed, let's say if you're running like nodemon or nodewatch or something like that, and it's going to be rerun. And now that your server has those updates, it sends a little message, and now the dev server knows that things are ready. So it can go ahead and send the updates, just the UI updates, the component updates, to our HMR runtime. And this part's important. We need to, before we actually process and mutate the DOM, we need to grab the new data first. Otherwise, we're going to run into that mismatch again with the place and location being different. So we're going to grab the location, and now we're going to process the HMR updates. And now we don't have that mismatch anymore. Now we have location, and everything just works. And that's how it's working in Remix. So like I said, that's called hot data revalidation. There's a little problem, though, which you might have noticed, which is that we have to kill and bring back up the server. And that can be slow, which is one problem. But the other thing is, like, what if you hard refresh or you click a button that hits a loader while that thing is restarting? Well, then things are going to break. OK, doesn't take super long, so like, who cares? But like, it's not legendary DX. We need to get to legendary DX. So let's solve this problem. So this downtime, bad news. Let's make it go away. So how do we do that? Well, we already know how to solve this problem in the browser. We didn't want to disrupt the browser from having to refresh and pick up changes. Let's do the same thing for the server. So we're going to use a little hot swap script for the server. And what this is going to do, if you're familiar with it, it's going to purge the require cache or do some import cache busting, and it's going to pick up the new server file. So I'll show some code for that in a second. But the idea is now that when the changes occur on the server.js file, our little helper is going to pick up those changes. It's going to see those, and it's going to process them. And just like HMR before, it's going to do like a cheap version of HMR for the server, and it's going to apply those changes to our server. So this is what it looks like in CJS. And you might have seen something like this in our templates before, like in our Express template. And you can see we're watching to see if the server build changed. Then we're purging the require cache. If you want the details, that's over here. But we're just getting that require cache cleared so that when we re-require the build, we have the new build and not the cached version. And then, yeah, I'll skip over this for now. And then here's what it looks like for ESM. Very similar. We're going to keep track of the build. We're going to watch. We're going to use this trick that I think V was the first one I saw using this, where you use a timestamp as a query param for your import, and that lets you do some import cache busting. Now, be warned, I think this will grow in memory over time because it keeps the old versions around, right? It's not like the require cache that like releases that, but no one complains about it with Vite, so maybe it's fine. I don't know. Try it out. And then we tell the dev server that we're ready, and that's how that stuff all works. One thing to note is that if you're using a monorepo and you're changing things in a separate package and you want those things to be picked up, you can also do the same tricks to bust the import cache or the require cache for those packages when changes happen. So you can watch those and then bust the cache, and it should work. Yeah, that's not important. OK, cool. So you've noticed that we've arrived at this state where we have a unidirectional triangular flow of data. That's pretty powerful. I've seen that before somewhere. I really think I've seen that before. So there's some hidden power in these triangles for some reason. One thing I do want to talk about, though, is that the app server is the thing that the browser always hits. What that means is if you don't actually make any changes, what you're hitting is the same code path that you'd be hitting in production, right? If you're not doing any node-m things with development, just for your own sake, not for Remix's sake, for your own sake, it's the same exact code path. All the assets are served from the app server, right? So all of that performance, all those bugs, all of your characteristics that you have around your app server are preserved in dev. And it's only when you make changes that those changes affect anything at all. And it's just pushing those changes up. It's not changing anything else. I think that's pretty awesome. So I'm really excited because the unstable dev server is about to be stable. It's like the thing I'm focusing on. We're so close. I can taste it. But I just want to drive home that legendary DX isn't, I don't think we've achieved it. I think this is one small step. There's a ton of things we can improve around DX in Remix. But I'm really excited about this. I'm excited to get your hands on it. Just remember that legendary DX is all about the ability to say yes when you're designers or when in your head you have an idea for something you want to do. You should be able to say yes and have that legendary UX come out of it, right? It's an enablement for that. So with that, go out there and build some legendary things.